So at the last Basecamp, where actually I got a big applause for stating this, is I have convinced a structural engineer to do work in SketchUp. And it actually didn't take much convincing, and I'll introduce him right now. It's David Zachary, and we have Jesse. Sorry, I'm bad. I only know him by emails all the time. So, and Ryan also in the back row. And they really jumped right into it. So we started doing a couple of projects, and they really had no choice like me. When you force yourself to do it, the best way to do it is to jump in and just start working in SketchUp and layout. And so over the last few years, we've done several projects together, and because the coordination is so simple when you have a structural model in 3D that's directly overlaid on top of an architectural model, it reduces our review time to literally minutes. Most of the time I just follow through the entire model. If I see something projecting in a way I don't like or want to change, we discuss it, or we modify what we're doing architecturally to hide it. The project that we're showing up here as an example is a project that we just finished together, which was a 7,000 square foot mountain contemporary home. A little different from some of the other things that you've seen that I've presented before. That has a lot of glass, a lot of open areas, which tends to mean a little bit more structural complication to it. It's a project that is right now under construction. They are just breaking ground and digging footings, and it went through the building department with absolutely no comments whatsoever. The permit was issued without returning it back to the architect. I mentioned this in our last meeting. That put me in a little bit of a panic mode because I knew on my end there were a few things I still needed to button up and get to the contractor before we left for Basecamp, because they are building away. So with that, I'm going to let David talk and tell us how he uses SketchUp. I think you'll find it enlightening. He uses a lot of the same type of system and setup that I use, but he has really developed it to be extremely efficient for his use. So without further ado, David Zachary.
Thank you. Okay, so again, David Zachary. This is Jesse Brown and Ryan in the back. We've got some swag back there at the end of the show. Please ask questions. We're here to answer your questions and give as much knowledge out as we can on this. I'm a licensed engineer in California, Nevada, Washington, Oregon, this state, and Hawaii. We have offices in Tahoe and in Hawaii. That's basically Lake Tahoe and obviously the Hawaiian chain there. And we do work closely with Nick. What we're going to talk about today are the early days when we would, how we transformed into SketchUp through AutoCAD. The 3D modeling process, how we actually build the 3D models, how we export those to layout, construction document labeling, structural detailing, creating full PDF set, Nick's check on the entire model, and then how we actually give it to the field three-dimensionally. And then we'll answer any questions, but feel free to just raise your hand. One of us will know the answer. I hope, hopefully. So everybody remembers 2008. Basically, that was the crash. The spigot literally just shut off, and then somebody took a pipe wrench and really shut it off. So I started looking for more and more projects, more and more architects to work with. And in 2007, we were still doing two-dimensional AutoCAD work, where we just layer everything on top, and we got pretty good at that. But I went and talked to Nick, and he said, okay, well, let's try this. Let's do some projects together. So we started out with him just sending me line work of his drawings down to AutoCAD, and I would convert that to our standards and create two-dimensional projects from his. But I had already went and started creating details. So I started with one detail, it literally took me, like an entire day to do one detail. And then the next detail was literally like 3 hours. After that, now it's down to like 15 minutes tops to create a full detail. So we started out with our first project. We did the entire detail set in 3D in SketchUp, and we created these 2-dimensional line work. And we found that Nick and I were going back and forth on this 2D stuff way too much. It took way too long. So we started completely modeling the entire structure, literally every stick, into Nick's models. Nick's models are really well set up. His process, we have literally duplicated. We've copied his process, and we follow it to a T. So
If I could interrupt.
Yeah.
One thing which was pretty striking on this was this project was actually a very complex project. It was not something I probably would have dove into if it was my first time with SketchUp, but Dave wanted to, and it's about a 5,300 square foot home, but it has a lot of oblique angles and all types of different covered roof area. It probably has a roof area for a 7,000 square foot home, and it has lots of different gables and turns and plate heights and pitches and levels, but he dove in full force.
And by doing so, we actually found that it was easier. It's actually easier to build these things 3-dimensionally than it is to try and build it 2-dimensionally. It took me about 10 years to think 3-dimensionally from a 2-dimensional AutoCAD drawing. Here, I don't have to even think about it. I just draw it. Just start putting in the members and following the process down, and the plans are created. This literally took us 1 month to complete as a first project in SketchUp, just with actually 1.5 hour lesson from Nick. That's all I had. Today we can do a project like this in about 2 weeks, and we think we can actually get that down to a week. Potential problem areas like all these gable ends, all these roofs coming in together are easy. They're really easily seen. All the connections are easily seen by just looking through the model. So the modeling process. So here is what we get from Nick. He sends us his entire model. He's got, if you've ever seen one of Nick's or read his book, he's got very few layers. And we can pick these models apart very easily to see what we need to see. So the first thing we do is we take all his scenes and we remove them. We delete those. And then what we do is we take his entire model and we group it into one layer. And we'll see why here in a little bit. And then Jesse here wrote our own Ruby script for Zachary Engineering that when we run it, it's going to go ahead and populate our entire model, everything we need. So with one click, all of our scenes are created. All of our layers are created. We basically start with STR, and then we go by level. We only need 10 layers per level. That's it. And so a 4-story is 40 layers. That's all we need to work with and create everything into layout. These scenes that you see up here, we've abbreviated them so that they all fit in one spot, and they're just, one might be upper framing, so it'd be UF. So it's just nomenclature we know. So then we take his model and we group it into one, and we put that on what's called architectural SketchUp model. So with literally one click, we can turn his entire model off. But we've got all his layers still, so we can actually remove a roof, remove upper floor walls, remove upper floor diaphragm, so we can look down and follow load paths. We've created a component library that includes dynamic components. What we do is we bring this library into our model that we're going to be creating. Each time we do this, our dynamic library increases, but really this is all we need right here to generate the entire model. Some dynamic components like the shear walls back here are smart enough to, I'll let actually Jesse talk about those. He created them.
Okay, so you can kind of see the colored little walls back here. Not a great view. When we take a look at the model a little bit later, you'll see them a little bit easier. But we actually went through and wrote in some dynamic component stuff that'll actually auto-calculate the height, the length, and then for later on in labeling and layout, in the model you can actually put in your shear number and it'll populate itself in layout for us. So it actually saves quite a bit of time, but the dynamic components are really kind of cool, kind of Excel-like functions if you can use them, play with them, a lot of trial and error, but once you get it, it can save a lot of time.
They're very key for setting up the model properly. So they're all labeled as we want them. We're basically going to create a generic model, and then we're going to come through and design it. So modeling the structure. By using the architectural layers as a guide, we can break the house down. We can pull the roof off, and then just start populating it with our components to create the rafters. So the first step is we literally pull the roof out, and then we put our dynamic components into them. And you can see we did some ladder framing here. So we have engineers doing these layouts, so they know how the structure is going to be built and how to properly put the rafters in. Walls are the next step, so we've got all our rafters built, and then we take that layer off, turn that layer off, and we end up with this, and then we can actually just put in our dynamic walls in here, stretch them out, and what we do is, once again, it's an engineer setting these up, so we turn the top of the top plate to a green, which indicates it's going to be a bearing wall. So we know that that wall is going to be loaded, and that wall, really that load needs to get to the ground. We then add beams and columns as necessary. Again, we know where the load path is, so we can add in generic beams that are, again, dynamic components, and basically just work our way down through the entire structure, building just a very basic model. It takes about, right now it takes about a day. Go all the way down, add perimeter footings in, and then we'll add generic footings in that can be sized or replaced later down the line. So once we've completed that process, literally in a day, this is what the model looks like already. And if with one click we turn it on, all this information disappears into the architectural model. Do you have that up? We can actually show that.
Sure.
So here's our entire model. We've actually built our grid lines into the system. So when we're talking with Nick or any architect, we can describe a certain area, because when he says it's the media room, I'm like, well, I got to go back and find where the media room is. So with one click and
On
a
a
faster
slow laptop.
computer, there's the entire architectural model. And if you look through there, go ahead.
Yeah, and so David will then send me this file, and I can just walk through the project and in a matter of minutes see every component that he's designed in the structure, and I can just toggle on and off that architectural model layer as I'm walking through to really see where every aspect and component of the structure is located. This model was a good example. After going through it, I only found one thing, and it was the steel flange on one of the moment frames was protruding into the space. So we decided not to modify the beam. We only have to fur out one side of a wall to hide it. So it's very simple to have that covered. So now, at this point, the entire structure needs to be designed. So again, we're in Tahoe. We have the heaviest snow loads in the continuous United States, and we also have heavy earthquake loads and also heavy wind loads. So designing these things is very complicated, both vertically and laterally.
So we have to be very careful in how we transfer these loads down and make sure nothing's missing. And SketchUp has really helped us out in this arena in that we can follow the paths of every single member. So we start with one rafter. We take worst case rafter in several areas, and we will load it in our our calculation software. And then what we do is we turn it orange and we give it the calc number for reference later. So calc 1.2, you just go to the structure, you can find 1.2 here. It's also orange, so it also shows up in the plan set. So if a plan checker is looking at it, for instance, they can also find it very quickly. And here's an example of that. You can see the green bearing walls. So this has 3 points of bearing. And we changed it to orange and given it that, basically that calc number. And just the same way we built the structure, we're going to design it. So here we have a beam, and we've gone ahead and designed this beam. It's calc 1.5, and what we also do is we put in the max point loads in each bearing point, and just from knowing, we know whether we need to either calc these support members or just call them out as what we know they're going to need to be. In this case, 6x6 and a double trimmer back here. That's got 2.2 kips on it, and I think that's 8.4 kips. And again, we can take a look at that. And we don't need to rebuild the wall here. We don't, because the way we stack things with Nick's process in layout, the beams will be on top of the walls so that they can easily be seen, and the posts will be on top of the beams. We don't need to rebuild this section. We can just let that top plate run long and it won't be seen. So we can look at, with the architectural turned on, everything disappears. We know that's a good member.
So what's interesting too here is looking at how a structural engineer is applying the use of scenes. For instance, I have one scene for editing called working model, and that's what I use. David's using some of his scenes specifically for calc locations and ease of finding those elements.
That's mostly actually for the presentation.
Oh, is it?
Yeah, we have our basic scenes for. I know. I didn't want to be misled. Say again.
Is the number of the load, is that part of the dynamic component?
Yeah, we name it. We'll actually name this beam the size. I think this is a 6x12, and we put the calc right in there so that when we go to label it, we just literally double click on it.
We label it entity info, though, not the dynamic.
Okay, yeah.
So that the text that's floating, are you putting that in manually, or is that part of the text?
Manually, yes.
Okay, thank you.
It's a separate layer. The load you see here,
Yeah.
and here, and so it doesn't show up on the plans.
Okay, yeah.
It's just there for our reference as we go
I didn't
through.
know if you'd built that in somehow magically.
Now, maybe later, but
That would be nice. Yeah.
Should be able to do that.
oh my God, no.
What question?
Cancel, close.
I was just trying to show.
I thought it crashed.
Yeah. What was I trying to show?
I don't remember.
Okay.
Moving on.
All right, back.
Hold on, right here.
You put all the layers on one layer, layer 0. I saw it just then.
Yes.
Do you rebuild your layers, or is that you just do that for analysis, structural analysis
Well,
purposes?
we do the same as Nick.
Yeah, I draw everything on layer 0.
Yeah.
And then only once it's composed into a group or a component, then it's assigned a layer.
Right.
Right. So our entire roof rafter system, drawn on 0, made into a component on layer 0, grouped, and then added to a layer. So the entire group's a layer. So
Okay.
one click of a layer turns off the entire roof system.
Thank you.
Once each component is designed and labeled, this is what we were just talking about. We actually name it. what it's going to be. In this case, it's a 5.5 by 12-inch GLB glue lamp beam, and we put the calc number associated with it. And then we can literally go in and label this in layout. Can you show that real quick? I'll have Jesse show you what we actually do in layout to quickly label a member. Obviously, this laptop's a little slow, but
All right, let's look at that same beam, which is this one here. 1.15, which we just saw was a 5.5 by 12, I think. And so we look here, top right, we see that call out. So if we go into layout, go up here to our label tool. This was great with the latest layout update. It lets us do stuff like this now. That's if it wants to run. Come in here, link into that component. Okay, so we have a couple options. It's a really basic component, so here we are. There's our label straight from the model. Come on, layout. And there we go. Now leader.
we don't like the leaders, so it would be nice. So we just give them a stroke of 0. And they basically disappear. That's how we like to see things labeled.
There you go. There's the label.
So in the future, I'll show later down the line, we'll show how we'd like to do this in the future. So we basically transfer all these loads until we get down to the foundation. Lateral design. Like I said, we're in heavy earthquake. We've got 20% of maybe 300 PSF snow load up on top of the roof, or about 4 feet of snow on the roof. We shake the bottom, we got to get that load all the way up to the top and then all the way back down to the ground. So shear walls are exceedingly important up there. Hold downs, everything's got to transfer perfectly. And once again, SketchUp really helps us transfer these loads right to the ground. So go ahead. We're going to show you what we're looking at. So here's our shear walls. The pink are shear walls above, and the blue are shear walls below. So we can easily see what stacks and what doesn't stack. Here we have a non-stacking shear wall. Here we have a non-stacking shear wall. So we know if we need to put a moment frame in. So with just literally one quick scene, back to we see we need to put a moment frame under these shear walls that are coming down above. So back to the presentation. Really, really quick. I'll let Jesse talk about these shear walls. We've made those a little bit smart so that it's easier for us when we're doing calcs.
So we ran into an issue of a very, very tedious trying to label shear walls, and we figured, well, how do we make this faster? And so lots of Googling and Sketchucation and as much as I could possibly look up to figure out how to do it. And so what we ended up doing was we found dynamic components. And so within those, let me turn on just a shear here. So within these shear walls, when we get them and we match them to Nick's model, so we know where our wall widths are, we can come in. This is bugging me. We can come in here and take a look at the dynamic component stuff. So as these are designed, this is what we can use. It comes up, auto-populates the height of this shear wall here, which if we want to check it real quick, 9.5. There we go. We're looking at a length right there, and a shear label that comes in and is important with the actual labeling of the documents. And we can actually go in and take a look at the equations. This is where anyone was in the presentation last night kind of got an intro to dynamic components. But we can see in here for the height. Oh, that's not a good one. It's going to be redrawn. Go this one. Oh, you don't like me right now. Weird.
All right. Well,
but basically, it's an Excel function, if you will, that'll go through and input that data, and as you change the wall, you can redraw it, and it'll pop up with all the new information. Easy to use, easy for calculation.
it's easy because we can look at a shear wall and throw the numbers right into our spreadsheet for designing. And it's also easy because we can label them and lay out quite easily. Once the design is done, we go back and we change the labels inside them, so it's literally just a click, and we can label the shear wall in layout. So once again, oftentimes we end up with steel, a lot of steel in Tahoe, and we actually design the steel connections for steel shop drawings in the model, and then we pull those out and we'll make them into steel shop drawings. So when Nick has to review our steel shop drawings, he can literally go to the model, and also we send him a set of plan sheets. But these are actually built into the system, and we can show you in SketchUp. Zoom into there in the corner.
Ah,
My fault.
that was your fault. Okay.
Yeah, we've got all the connections in here, all the coves for welding, all the stiffener plates, all the ears for posts coming down to it. Everything is in the model and is also referenced out for the steel shops. So once again, once this goes to Nick, Nick takes a look at this and says, wait, that's sticking out 1 5/8", and he can make a decision what to do or direct us what he wants to do.
So Dave's gonna be out on site with a plasma cutter. After the inspector leaves.
Exactly. Actually, it'll be Jesse. Other situations require strong walls, Simpson strong walls. We use those a ton. We've actually had Simpson come into our office, and they've actually created more SketchUp components for us. You can almost find any hold down, any strong wall in SketchUp now, and you can just download it right to your model. We've actually had projects where we've input every single hold down because it was so complicated that we had to make sure that every hold down made it to the ground. So we literally grab their components and we dump them in.
Is the Simpson stuff dynamic?
We make it dynamic, like the strong walls. They do a little bit different process than we do. The way we like to label and stuff, they group a couple different things. We like it faces and groups for their strong walls. So then we'll go through and actually make them dynamic. In our initial library, that's where we do all that little rough handwork, and then we can grab them from there. Originally, Simpson only had about 2 of their sizes of strong walls up there. And I sent our regional rep an email like, hey, you think you can get the other ones in there? We kind of need those. Like, yeah, give me a week. And sure enough, a week later, we had all the strong wall sizes. And so those are up there on the warehouse now for everyone. Really kind of cool.
And one of the main reasons we're using SketchUp nowadays, does anybody watch Shark Tank? Mr. Wonderful? You don't do anything unless it makes you money. And this has sped our process up so much that it is actually making us more money per project. Main reason we use SketchUp.
Do you have a percentage of what you think SketchUp has saved you by using SketchUp over open methods?
Cut a project in half.
I know every project is different.
Timeline.
You would say cutting it in half?
Yep.
Impressive.
Our details used to take 3 days. Now it's literally 3 hours
Do you
tops.
talk to new clients that come to you with, say, other program files besides SketchUp and say, hey, we use this, do you try to encourage them to use SketchUp?
Actually, we can take Revit, we can take ArchiCAD, all those convert to SketchUp, and we use it right there, and then we can give it back to them, and they can put it back in their software.
You're gonna try to convince them just to switch to SketchUp.
I've said, hey, you got to get Nick's book. Another shameless book. But
Thank you.
Did the voices go down, or did they stay the same?
that's the beauty of it. What would Mr. Wonderful do?
Well, now that I know it's 50%.
Okay. So now we've got the entire model designed. So every member is smart. Everything is done. Everything is to exact size. We use import SketchUp I-beams to this thing, and they did a great job of creating those, and they dump in perfectly. They're exactly the size. So everything's within probably 32nd, 64th, something like that on the entire model. And all we have to do is export it because we've set up all our scenes we're gonna just dump it right into templates we have for layout. So since we have, in the beginning, we had created all these scenes with our Ruby script, we have all our layers set up in our templates. All we have to do is a relink and the entire drawing gets populated just the way we want to see it.
If you back up one scene, one. Just reading it.
Oh, there's none of that. Memorizing it, maybe?
He's seeing some typos.
Oh.
Thank you.
So once it's populated, this is what we see. We have, when we're working with Nick, he sends us his layout files. So we can match ours up to exactly. So if you put this on a light table, our drawings will match up exactly to his. Literally every sheet. And then we just, literally, we had go in and, oops, sorry, I forgot. You want to talk about auto text?
Oh yeah, we started maybe a few months ago, 4 or 5 months ago. We started playing around with the auto text and layout. Really kind of handy if you can name things correctly. Your page numbers. If we look, yeah, you can see the mouse. If we look down here, this is auto text, and then in our title block here, this is all auto text. And actually, now this is all auto text too. Up here in, I'll just show you in layout real quick. Let's go file. And so we have auto text. And so we can see here that all this stuff, populates itself. And it's really handy here with the page name and the page number, because if we've had a couple jobs where you get all the way to the end and then, oh, we need to move one page down and move it up. And what ends up happening is down here, our little bubble is what always gets missed. We forgot to change this, and now all of a sudden you have conflicting numbers and all that kind of stuff. But if we run into this real quick, let me turn this off. Oh no, no instructor. That one. Nope, not that one. What about title block? That one. There we go. So if we go in here, we can see that it's populating it based on this name right here. Page 6 is upper roof framing plan, upper roof framing plan. Down here, S point, page number 6. So if these move, and let's just do that for the heck of it, right here, boom, 1.5. This one has changed to 1.6. So makes it really kind of easy to change things around.
Future goals. We can isolate just the beam layer. And with Ruby script coming into layout, we know at some point in the future, not soon enough, we want to write our own Ruby script to just window over all the beams and have them label exactly how we want them. Everything's already smart inside there. Same with the posts. That would save a huge amount of time in just labeling things other than clicking on them individually. So I think we've been very successful at letting SketchUp know that we want that. If not, we want it. So if we can cut our labeling by half, that's how I think we can actually get these down to just over a week. We can do a full set. For details, we have over 500 details, and that's just come over time, and they're very easy to draw and very easy to change and resave. We've come up with a naming convention so that we can easily find them. Another thing we're asking SketchUp for is a search engine on their scrapbook. Simple search engine. We could find these details really quickly, see them on the plan, and just slide them in. Would happen very fast, but once again, so we have to back out, go into a Windows search. We can search for FND, that's foundation, and then how we label them. We can easily find any detail we want, or something similar and modify it and rename it to just drop in. That's how our details went from 3 days to just literally 3 hours, and we're done. And that includes all the custom details we have to do. Here's an example of a full detail. We try to keep everything organized and simple so that this area is clean and you can see everything. Every detail we draw is in 3D. Anybody wants to see a full plan set, there's a full plan set called Crooked Tree. What's that room called?
The Knowledge Cafe.
In the Knowledge Cafe, that has an entire design set from Nick and myself. Mine are all the way in the back. Not many people make it that far, but you can see a full set of plans in there.
You ever print 3D PDFs in these?
3D PDFs?
Yeah.
No, I've never done that, but I saw that in a seminar here, and that would be really neat. In fact, what we would really like is to be able to label the model where these details are. And did you guys see the iris? Be able to walk through, point the laser at that section, and have that detail highlight over here, and you can walk around it. But they said they're nowhere near ready for that yet. But
That's when we won't have paper plans.
yeah, we'll be just sending these out to the field. Oh, yeah.
In that previous screen, is your text in SketchUp or is that the layout?
All the text is in layout. Everything's, yeah.
I'll go to
We'll
next.
take a look at that.
That detail was drawn in layout?
No, the detail's drawn in SketchUp, and we're looking at it in layout, just a view of it, and then we're labeling it there and dimensioning it if we need to.
So here you end up with structural drawings that look far more artistic than you'd expect. Usually structural drawings really don't pop and read well, and the 3D aspect, and you see Dave's even using shadow, he uses fog, just like I do in some of my details, that really tell the story so much better than anything you'd see in a 2D scale.
So what you see here, we have the title and all our callouts here. These are all layout. Now if you see here, there we go. This is actually a SketchUp model. So we can actually go in here.
You're skating on thin ice with this computer.
I know. I know. But so here we are. Here's that model within SketchUp.
And you can see we've got, go back up a little bit. This one has hydronics in it, so we actually go ahead and put the hydronics in. We're just able to, with 3D details, we're able to put more of Nick's information in here and just portray a better picture, and ultimately it makes it for a better project. Like he said, when he said we had no comments coming back from the town of Truckee, that means something. The town of Truckee is hard. They're really hardcore on the code, and to be able to put out a project with no comments through them is a pretty big feat. Here's a full detail sheet example. This is maybe 3 minutes. Everything's in ScrapUp. We drag it in. Right here is our design information, so we can change that very easily with on page 2 of the calcs is all this information, so we match it. And then these are literally details that we just drag in, and eventually we'll put auto text in there as well, so they label themselves. Finally, I know we're way early here, but we actually create a full PDF set, and we send that to the architect. We also send our model to him. And so maybe you could talk about what your process of checking our plans is.
Yeah, so the plans, in the old days, I used to have to go through and look at all the framing plans, look at all the beams, and then a lot of times I would actually model them into my SketchUp model if they were greatly different from what I have. Over time, I've gotten pretty good at guessing beam depths, at least, for most of the larger spans, and understanding where there's going to be steel. That big opening that we were looking at in that moment frame, I knew full well that was going to be steel through there because it was carrying a second floor of the roof and no shear wall in that plane. But now it's really simple because I just literally just walk through the model, as I mentioned, and I just look for those areas of discrepancy that might become an issue for finishes or anything architectural. We never run into the classic issues of a header over a stair anymore, any of those things that typically became a problem in the field. So it's really cut down my time in the review, which has really helped, as well as when I produce the full set of drawings. You know, I mentioned this in my last presentation. It's really important to me how the drawing package looks as a whole. And with David actually bringing this now into SketchUp and adding all of the, you know, the color, the 3D aspect to it, and really taking care in how the drawings look, it makes for a confident package. And I think that has a lot to do also with why we don't get all that many comments, is they see a project set that is really well coordinated, extremely detailed, that in the end they know that we've actually done our due diligence to make sure this project works. So that alone brings so much confidence, not just to the plan checkers, but also to the contractors. Sometimes if they're a new contractor who've never worked with us and we plop down that 82 sheet set for a house, you know, they at first taken back a little bit, but as soon as they start to dig into things, they realize that it's just going to make their job that much easier and that much more successful, and then they actually will be more profitable on the home.
We actually put 3D isometrics on our cover page. We did this because it was cool. We thought it looked really cool. But I noticed out in the field, contractors are looking at them. They're just looking at them to see what the structure actually looks like. And we also have them come into the office when they're in the bidding process, and they can walk through the entire structure, which really helps them understand the 2D set we put out.
So we're using like any iPads or whatever out there, so they can click on stuff and see it immediately on the site?
Yes and no. We're doing live cubes, which we're going to get into in a second. Here's a live cube that we'll actually create with LumenRT, and we'll give it to the contractor. It's an executable file. All they need is a computer with a good card in it, and they can actually run the 3D model and walk through the entire 3D model that's used to make the plan set in the field.
Yeah, how many structural engineers do you see doing rendered animation?
Yeah.
But these live cubes that LumenRT produces are really valuable. You know, number one, you don't have to have anything special to open it. But they have the ability to have it open while looking at the drawings. The two are exactly the same thing, both architecturally or structural, to really see what's going on in the project. So we found these really useful, and so now we have contractors in the field that will have their computers open. So there are some that use iPads, but then you're somewhat limited to PDFs and animation and JPEGs, but I believe LumenRT is coming up with a mobile app shortly where they'll be able to do live cubes on iPads as well.
That would be great. They could, when they get to that level, you're going to see a lot of iPads in the field where, you know, employees have something they can look at to see the structure 3D. We see one of these is in the field right now, and the contractor says he uses it at least 3 times a day. They'll pull a guy in, okay, you're working on this area. They'll show them the area, they'll show them the 2D plan, they understand it immediately, and they can go build it. And it was quick, but questions?
You guys just anything for 3D analysis, you know, like multi-frame, or do you go back and forth from that, SketchUp to that, or are you doing, you know, are you taking this structure into a 3D analysis program while you're rotating?
No, we do all that by hand. I have a little bit of a problem with that. I know Revit does that, but you can propagate an error real easily and never catch it. So we're good at picking out which members to design, and so we actually design, you know, every member that you see is orange and has a label to it. We designed it.
I just get a lot of questions on that from the timber frame side of things, so bringing it into 3D analysis for lateral loading and all that. I just didn't know if there was some secret magic trick I was missing somewhere to help speed that
Secret
process
magic
up.
trick is you hire a Zachary engineer. We got really good at doing lateral analysis because of where we live. And Hawaii is actually really easy compared to what we do in Tahoe.
How are the framers in the field handling the plans? Are they having a plan set as well as a tablet or a laptop or something with your file as well?
Well, they get a PDF set right away for bidding, and then they get a full plan set, and they also get a live cube. So they have the 3D structure in their hands. When they see the color drawings, they're a little bit drawn back because we have to print in color because our legends, everything is in color. So to print these in black and white just wouldn't work as far as how we reference everything. They're a little bit drawn back, but they start looking at these things and everything's actually to size. And when they get into the 3D models, they become very comfortable with and almost relying on using our plan set.
I have a problem with the framer coming in, sitting behind me on the computer wanting to see details about it, and he can't.
Oh yeah?
Structural beams and stuff, because he can't navigate very well.
When we see them come into the job shack to look at it 3D, there's somebody that knows how to get through it, showing them where to work. So it's not, they don't all have free access to that. It's how I've seen it run, and it's not how I determine it, but that's how they seem to run
Yeah,
it.
it's usually left to the superintendent's hands. Most of the framing crews that come out, I wouldn't exactly say they're all tech savvy, so,
Yeah, that's been 100.
yeah. Hopefully by then, the level of tech savvy kind of goes together.
Yeah, we've actually found that our plotter and our supplies have gone way down because we're issuing PDF sets all the
Yeah.
time. And we really only have to print that one set for the building department.
Yeah.
You have a question?
Shop drawings? Do a lot of structural steel and your detail actions?
Yeah, we do our own steel shops. There's an example actually in the hallway. It's a full page of steel shops that we provide. Everything, yeah. Every piece is modeled, labeled, and then put back into the model. So, yeah, we detail the heck out of those things. Yeah.
If we, as engineers, contractors, whatever, wanted to adopt Nick's flow,
Mm-hmm.
is that what this tells us? Exactly?
Yeah, so this is that same workflow in a different application.
Right.
And so, I've had that question quite a bit on the book, would this apply to me as a cabinet maker or woodworker? And I said, yes, some of it, no, because we're talking about site design, but the basic system and how it works is still the same.
We adopted it almost verbatim.
And then, yeah, David just then modifies it for his needs with regards to layering systems and scenes.
Yeah, we came up, with our own conventions of tracking loads and whatnot. That was all us. But without putting everything on layer 0, making the component, and then how we group things, that's the real power of it. Without doing that, and making things dynamic now is just, the labeling is so fast, and it's gonna get faster. Right, SketchUp? Where are you guys at? Yeah.
Would there be any benefits that you might have explored of using the classification process in SketchUp to help you with the dynamic components, labeling?
I looked into that, and for what we're trying to do, not in particular. I mean, I haven't spent hours and hours and hours trying to play with it. I looked at the classification stuff some, and it was bugging me. So I went ahead and wrote my own, dynamic stuff in there, which, maybe it's just me, but it made more sense to me. I mean, potentially, when we deal with other people that are going back and forth between programs, maybe, but not necessarily at the moment.
The approach might be talking structural engineer to architect.
Right. Yeah, it's worth looking into later, but it was one of those things like, let's get this done and get moving on it. And
And then a follow-up, any idea how far we might be from detecting collisions in SketchUp?
I have no idea on that one. We do it all visually right now. You can see some of our stuff overlaps, but it would be nice. Nick's now drawing all his MP&Es in, so we give him our structure and he's drawing all the MP&Es in there. So we're literally putting out a full commercial set for a residence. And they're all scaled.
Would you say that SketchUp has helped you to find, come across errors that were harder to find in the past? The program help you to find those errors? Or
It does
obviously correct them,
visually.
but visually, does it help you in the process of your process to find them?
Yeah, Yeah, we find, well, we don't find many errors with Nick. I mean, his models, if you've ever seen them, they're very well thought out, and the load paths are actually very well thought out. But yeah, we have seen errors. I've also had contractors call me and say that there's a problem with the plans, and I said, no, there's not. And they said, yeah, this is supposed to be like this, and the moment frame's off, and it's the wrong height. I said, no, it's not. You dropped the beam when you were supposed to hang it. Written all over the plans, it's in the model, everything. And they're like, oh, my bad, sorry. So these really, how it's modeled, it's really difficult to be wrong. Not saying that I'm perfect.
Yeah.
Better than I was with SketchUp. No.
It's too late, it's on.
Yeah.
Just quickly, roughly on a project of that size that you're showing, you said it's roughly 80 pages for a permit set. Of that, how many are the structurals?
We've got 10 to 12, 10 to 15. Oh my God, it's pretty small. Our scope's pretty, and if you go look, you can see what a full, how big is that per tree?
That's, I think, 82 sheets.
How many square feet?
7,000 square feet.
7,000 square foot house, you know, that took up 3 sheets just to do one
the
level.
framing, yeah,
So,
sure.
you know, that one, there's obviously a lot more, but in general. Any other questions? Rick?
You were showing in the last session site design and how you start to lay out your footings. Are you, once that model goes over to you, are you guys designing the footings that kind of over that then, and that's going back to Nick, and you're adjusting that in your model?
Yeah, I will do that. I'll double check my footings based on David. So a lot of times when I model it, I won't do anything central footings for pier footings, things like that. And then I'll copy and paste their foundation into mine. What I'm doing is I'm laying out a really basic 8-inch stem wall with a 16-inch wide footing, and I'll adjust it for height based upon the site so David can see this is the height we need in this area. And actually, a lot of times I give David the site model as well so he can really see what I'm looking at for site work, because I also have him do some of the site retaining walls if the project has them.
And our retaining walls are put 2 sides with the toe, the heel,
Yeah.
the thickness, everything, so that if Nick had those furred out, and the client comes in and says, hey, I've lost, 10 square feet in this room, and I needed all 10 square feet because we had to fur it out, and he had an 8-inch wall, and I wanted a 12. We put that into the model, and that's immediately flagged.
Yeah.
So that.
Yeah, there'll be lots of times where we'll have a portion of a home that just slightly retains in the back 2 to 3 feet. And if the room's really tight, I'll ask David, can we make an adjustment in the stem wall thickness as it rises up into the room? So I only have to put a little bit of furring on that wall. And so we'll do that. So there'll be a lot of times where we'll have a 5.5-inch stem wall come up 3 feet and then step down to 8 inches as it goes below the crawl space.
One of the reasons we have so many details is he asked for that, we provide it, we name it, it's there.
What kind of wind loads do you design with?
We're usually 120 miles per hour, I think. And then,
101 to 120.
3 seconds.
Ryan, you're 130, and then that comes down to, I think, 101
Yeah.
miles per hour.
There's always seismic.
Yeah, seismic in our area, we do both because we have to look at hold downs and what shear value is, but in general, seismic controls in our region. I imagine out here too.
Sorry, I didn't catch what states you're licensed for?
Oh, California, Nevada, Oregon, Washington, Colorado here, and Hawaii. 6 states.
Some part of it.
It's easy to get any state because once you get California, it's reciprocity. And then pay them. Any other questions? I think that's over here.
Yeah, when are you gonna make a book outlining your process?
We're actually talking about that. It might be an addendum to Nick's, or I don't know. We've talked about it. I need to get together with the guy that helped him write it and see if that's something people would want. I kind of want to see the response he gets too. We're talking about also putting our details up for sale. So we've created all these details, and they're kind of site specific to Tahoe or to snow country, heavy loads, but might be something we look at in the future.
Yeah, the detail libraries are the biggest challenge when you completely convert, because if you've used AutoCAD for years, you have your giant library of details, and you pretty much are taking those and just throwing them by the wayside, diving in and modeling. But that curve's not that long, it really isn't. For Dave, it was incredibly fast. For me, it was a little longer. You know, just architectural details, I just think have a lot more little things to look at. So I can't produce them quite as fast as Dave can get the detail sheet, but I think I mentioned I usually put together a full 9 sheets of details in a day and a half. That's fast enough for me.
We want faster. Yeah.
Is Nick are you gonna offer your details?
You know, we're talking about how that would work. Matt and I are looking at potentially in a second follow-up on the book that talks about the process of detailing. We go into it a little bit in the book, but just to show how I put them together, you know, I kind of do it a similar way that they do. How they populate their model is I have, you know, what I call a kit of parts, and it has components that are things like a stud, sheet of plywood, flashing piece, trim pieces, and then bring them all and compose them into a model and edit them in place. It works really well. It's very fast. It still isolates everything on their own group, so it's easy to edit and change things and create new details. You know, back in the day, and that's part of the problem, I've got probably half of my details or more were done the old sloppy way I used to do, which was just start modeling and go. And so a window detail may have everything just modeled together, bound together, with the exception of a component of a window. So the task I've got, and I have to do this anyway, is go back to a lot of those details to recompose them and make them so they're easy or easier to edit. So the answer is possibly.
Luckily, we didn't have to go through that process because Nick told us how to do it.
Yeah, I told
first
Rice,
time.
don't do it like this.
Yeah.
There's enough demand.
Yeah. Yeah, there might be.
Worthwhile. I guess further to that is that there's lots of parts and pieces already on the warehouse. You don't have to necessarily use what's already on there.
Yeah.
If you don't trust it, you can redo it, but you can pull the textures, you can add things.
Yep.
You can extrude things. There's so much information on
There is, and I maybe it's just me, but I'm pretty anal about that. So every single thing I download off of 3D Warehouse, I load into a separate file, and I dive into it to see what it is. So I don't all of a sudden bring in layers 1 through 72. Or
it's not inputted into your actual model. It's kind of that file.
Yeah.
Just as a resource file.
Yeah, so yeah, well, if I really like it, you know, because there's some models in there that I love, and I've gone in and just recomposed them because they're really good models. They just didn't have much layer management. Or you go into some, you know, and I love Kohler's depository there, but you go in, you click on it, and it's a group. Then you click it on again, it's another group. You click it on again, it's another group, and it's all the same group over and over and over and over.
Kitchen stuff.
Yeah, which I don't know how it got there, unless they're modeling it in some other program and just exporting it, and it carries whatever the properties of that other modeling system is.
Real quick, have you got any response back from the city, since your drawings have changed using SketchUp? Have you heard from them? They said they're happy, or obviously, or?
Well, usually when we first were bringing them in, it was, whoa, come over here and check this out. And I think they've been really happy to see, we'd like to get them 3D models. Their computers just won't, you know, they don't get really good computers. It just won't run the live cube. But sometimes the more information you give them can hurt you too. So what we're giving them now has been working out great. They like it. I think they're a little bit overwhelmed with how much information's there because they're not used to seeing all that. So they do get that thought process of, oh wow, these guys really thought this through. Send it on. So and we don't really get calls from the field.
No.
That's huge. That saves us a ton of time, saves them a ton of time. Yeah.
How are you handling the mission? Once you've sent all the documents to the field, you're going to send any changes back to the field. Your live model, it's okay. make the changes. and
Yep,
stuff.
we'll send them a new live
Are
model.
you keeping a document copy of the original before the revision, or working with the original on the revision?
We keep a PDF set, originals, submittal, and Delta 1.
I think you say on the model.
3D model.
No, we just keep updating it.
You keep updating it?
Yep, but we have the PDF set to look at.
See, I don't do that.
Otherwise, we end up with.
So
a ton of-
what I do is anytime there's a revision, that model is I save as the next number. So I might have plan 1, 2, 3, 4, 10. And so I've always got a copy of the original and then how it
You
was
have that record
modified.
copy that
Yeah.
says, this is what it was before we
Yeah,
changed.
that way if something ever happens, the unlikely something happens, you can always go back and say, well, you, Mr. Owner, changed it, because remember, here's the plan, and then here's how we revised it.
How do you provide information on the changes within that model to people who may be using it?
You cloud the drawing.
Well, if it's significant enough to affect the, like the live cube, we would just reissue a new live cube, because,
Yeah, but do you give any sort of notification that there's been a change so that somebody knows?
well, yeah, if there's a change, the contractor's usually the first to be notified once the change is approved by the owner.
We try to be a PDF. We keep one model going.
Yeah.
Whole time.
It's probably not as crucial for David to do that because the changes are always going to be initiated typically by me or by something in the field by the contractor, but they'll always call me first to let me know if there's any change, or the owner may. So I always have a copy of what has happened, and then David gets that information and makes the change.
He'll ask me sometimes, what model do you have in yours? And I'll tell him, and so we just click on it, and tells us what it is.
But we actually don't run into many field changes. And I usually head off most of those big changes before I send it to David. So, because I won't get David started until the schematic design phase is completely done and I'm about halfway through design development, then I'll send it to David.
Do you guys ever disseminate the actual SketchUp model to the construction team? Or do you like to leave it so you're giving them a render cube and they can't actually get into the model and pull live measurements?
We don't want them measuring stuff in the model.
Yeah.
You could throw an axis off and get a wrong measurement, and then they're going to come back and say, hey, I measured it right off the model. So we don't give them.
Yeah.
Any other questions? Thank you very much. There's swag in the back if anybody.
Hats, shirts.
Hats, shirts.